All right, well, next I would like to try another former finite state automaton. And we're going to go this time with strings that end in 101. So let's just get rid of that one. And let's get rid of this one as well. So here's our automaton for strings that end in 101. And looking at this, you can see that if I have a 1, I go to Q1, a 0 takes me to Q2, a 1 takes me in Q3, but if there's more input, I may escape from Q3 and go back to an earlier state. So only if the very last character leaves me in Q3 will I in fact use this automaton. Now I can try doing a literal translation of that into a Turing machine. And so let's go ahead and we'll create 4 states. And we'll mark Q0 as initial. Q3 for now we will mark as final. And again, let's just do a very literal translation where we don't actually change what's on the tape. And we always move to the right. And Q2 goes up here on a 1. Comes back on a 0. And cuts across here on a 1. All right, let's try this on, let's say, oh, it's not going to let me try it, so I'm going to have to argue what this would do. Let's try this up in the finite state automaton first on 10100. So this is a string that will not actually end in 101, but contains a 101 inside. And in the non-deterministic automaton, we process the 1, go to Q1, process the 0, go to Q2, process the 1, we're in Q3, which is an accept state, but we can't accept because we haven't processed all the input. Process the 0, we're in Q2, process the 0, we're back in Q0. So when we finally have processed all the input, we're not in an accept state. But now if I took that same sequence and applied it to this automaton as I've currently got it drawn, and I know how to fix that. Let's pretend we don't have, that is not a final state, and see if it will let us do the same thing. There we go. So 10100 again, this time with the Turing machine. And so our head is pointed at 1. We accept that and go to Q1. Our head is now pointing at the 0. That takes us to Q2. Our head was pointing at the 1, we accept the 1, and that takes us up to Q3. Now, if this had been a final state, our Turing machine was simply stopped. But this string does not end in 101. So this automaton, if I were to make this a final state, this Turing machine would actually wind up accepting strings that contain 101, not strings that end in 101. So how do we fix that? Well, with a finite automaton, we know when we hit the end of the input because there's no more input. in terms of a Turing machine, we've got this infinite tape, and we drop our input right into the middle of it, and it's got blank spaces on either side. In this particular automaton, we're always moving from left to right. We're never backing up. And so we can actually tell when we've hit the end of our input because suddenly we will be looking at a blank. And that's the clue we need to fix this automaton. What we will do is we will say, if when, yep, going to get rid of that. Try that again. If when I've seen 101 and made my way to Q3, the next thing I'm looking at is a blank, then I will come to Q4 and I will make Q4 my final state. Let's try that on the same input. One zero one zero zero. All right, our head is pointing at 1, so we will accept that 1 and go into Q1. Our head is pointing at a 0, so we will accept that 0 and go to Q2. Our head is pointing at 1, so we accept that 1 and go into Q3. Q3 is no longer an accept or final state, so we get to keep going. And our head is pointing at a 0, and that 0 takes us back to Q2. And our head is pointing at a 0, and that takes us back to Q0. Now our head is pointing at a blank, and we have no transition out of Q0 on a blank. And so we halt, not accepting. And so we halt, but we do not accept the string. Now let's try this on a string that does end in 101. Let's do 10101. All right, so our head is pointing at 1. That takes us to Q1. Our head is pointing at 0. That takes us to Q2. Our head is pointing at 1. That takes us to Q3. Our head is now pointing at 0. That takes us back to Q2. Our head is pointing at 1. That takes us to Q3. Now our head is pointing at a blank. And so we make a transition on that blank into an accepting state and accept the string. So I think this is a good example of how, we need to be a little bit more careful on what we choose as accepting and non-accepting states when we're working with Turing machines. This dodge of saying, when I'm looking at a blank, sometimes I can use that as a way of telling that I've reached the end of an input and then make a decision whether to accept or not, is a fairly common step in Turing machines. It's not a universal one, but reasonably common. You will see that fairly often.